So how is an ellipse defined? An ellipse is defined as, what does that sound? An ellipse is defined as the set of all points such that the sum of the distances to the foci are equal. So every ellipse is defined by 2 points known as foci, plural of focus, not foci, but foci, the plural of foci, yes, foci. Thank you.
But it's both. It says both guy.
Well, it's foci.
Yeah. He said both guy.
Well, Hochmuth is not even how you say his name. It's Hochmuth. Hochmuth.
Yeah, that's not.
Yeah?
Recording?
I am, yes.
Yeah.
Yeah.
Better gain popularity.
All right, guys. The ellipse is the set of all points such that the sum of the distances to the foci are equal. So that means that for every single point on this ellipse, the total length of this blue line, the two lines together, they must always be equal to each other. So these sums are always equal to each other. You can imagine you have a string that's tied to each foci, and then you're taking your pencil and you're stretching the string taut, and you're just moving it all around. You know what I'm saying? Visualize it in your mind.
It's calling it a stretched out circle.
Because a circle can be stretched out in different ways. And it's also not a stretched out circle. So not merely a stretched out circle. Anyways, yes. So now let's talk about some of the different parameters of the ellipse. And we're going to see how these relate to the equation that we have. So let me draw a large ellipse. So first we have a center. So the ellipse has a center, and this center is going to be given by h comma k, typically those variables. Center is h comma k, so that's the same as the vertex of a parabola, right? hk. We're also going to have our semi-major axis. Did you guys learn that in Algebra 2? Yes, you did. A is the semi-major axis. It's called semi-major because it's half of the major axis. So the major axis has length 2a, and the semi-major axis has length a. And then we also have the semi-minor axis. Why is it called the semi-minor axis? Well, it's because it's shorter than the major axis. So the short one is always the minor one, and the long one's the major. Okay? And then the 4 points at the ends. So this point, this point, this point, and this point, these are all vertices. And then the foci are going to be located here and here. So these are our two foci. And the distance from the center to the foci is going to be given by the variable c. Is that Lima?
Teachers yelling at their students. Wait.
I've never heard him get that loud.
They must have used AI.
That is Lima though, right?
AI catch them.
Yeah, it should be here from Lima's right there right now, right? That's not Lima?
No, there's no way.
That's fine. Actually, a junior high teacher.
Yeah.
I mean, there's nothing here. This is dirt on this side.
Really?
I mean, do you know any rooms on this side?
So if I just broke the wall, then
Yeah, it's
dirt would
dirt.
come out?
Yeah. It's a hill, right? There's dirt.
I thought it'd be like concrete or something.
Okay.
Fill the whole hill up with concrete.
There's nobody there. Oh, there's nobody.
Wait, so I mean, who's in that room? It's Hokeman's room, right?
That's oh.
That was not Mr.
Probably
Hokeman.
giving the closer to better, it gets better grades than
Don't get.
he's like no roads or A's, back roads.
All right, let's yeah, go figure this out. I'm so curious. Don't be obvious though, please. Okay, anyways, C is the distance between the center to the foci, okay?
Wait, what do you uh
So this is one of the focus. This is one of the foci. It's a focus. And the distance from that point to the center is given by C. All right,
so C acting as P in this form.
who's it?
It's Lima, but he was more.
So it is Lima.
I like asked.
That's impossible. I'm telling you, it's Lima. I'm sure he wasn't mad. He was just loud. He was just yelling.
He sounded like a big guy with a beard and a.
No, sounded like Lima to me.
Yeah. That's
Anyways, C and A and B are all related. You would think it's A squared plus B squared equals C squared, but unfortunately not. It's C squared equals A squared minus B squared.
also that bad.
Why is that?
I think if it's like something else, then like it's a hyperbole.
That is because this length is actually A. You can go home and figure that out for yourself.
That's so cool.
Right.
Yeah,
It's diagonal.
yeah, but diagonals.
I mean, it even looks the same length. It's A. It is right. Just use your mind. Think about
So
it.
can we just do A
Wait.
squared equals B
Wait.
squared plus
Oh.
B squared?
No.
That's because the sum of the distances that is always constant for an ellipse, it's always 2A.
What?
Never. What's today?
2A is the sum of the distances to the foci for an ellipse.
So if you want
That's a hypotenuse, and it's the same length as the side.
No, A is this entire length, right?
Oh.
C is this length. Anyways, go home and think about it. Use your brains. Think about it. It's not that hard. But any questions about this? A, B, and C are the most important numbers for a whatchamacallit.
Same with the seats.
no.
All right, so let's talk about the equation for an ellipse. There are two. And the equation for an ellipse depends on which one's the longer one and which one's the shorter one. So whether whether it's longer vertically or longer horizontally. So if it's longer vertically, then let's do the longer horizontally first one, actually. If it's longer horizontally, then it's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. So notice several things. The h is always with the x and the k is always with the y. That's very similar to the parabola. Yes. Yes. No laptop. A is going to be the semi-major axis. And so in this case, we're looking at a horizontal ellipse. How do I know it's horizontal? That's because the semi-major axis is in the x direction, right? So that's why it goes with the x. On the other hand, if we have a vertical ellipse, then x is actually going to have the semi-minor axis. Sorry, y minus k, right? And then the y is going to have the semi-major axis. Okay, so in this case, the semi-major axis will be vertical. And then finally, notice that in order for it to be an ellipse, it has to be a plus sign, and they have to equal 1. So the right side must be 1. If it's not 1, you have to divide it by a constant such that it equals 1. Otherwise, it's just, you're not going to get the correct values for the semi-major and semi-minor axes. And then it has to be a plus sign. If it's a minus sign, then you have a hyperbola, which we'll discuss next class. Any questions? So personally, I have an easier way of thinking about this. Instead of using two different equations, instead of using two different equations, I personally like to think about it not in terms of semi-major or semi-minor, but just in terms of x radius and y radius. What do I mean by this? I personally prefer this formula. Does this make sense?
Is it r times x squared?
No, it's r sub x squared. Okay, so in this case, I'm letting the variable r sub x refer to the quote unquote x radius. Okay, it's not actually a radius because for an ellipse, there is no radius, right? But I'm saying that it's the length of the semi whatever axis in the x direction. Okay. So that way I don't have to worry about whether which one's longer, which one's shorter. I always know that the quote unquote radius in the x direction is always going to go with the x minus h squared. And similarly, the radius in the y direction is always going to go with the y minus k squared. Okay? So that is how I think about it more often than not. I may. 10 more seconds. Questions? So sometimes you're going to be given A and B. Other times you're going to be given B and C, and you can find A, right? Because we have C squared equals A squared minus B squared. Let me do 1D as an example, and then you guys can... Well, actually, I'm going to finish my whole lecture, and then you guys can start. It's not that hard. Let's do 1D. So in this question, sorry, there's something very important that I forgot to mention, which is that the foci are always on the semi-major axis. Okay, very important. The foci are on the major axis. They're always on the longer one. Okay, that will help us do 1D. Okay, so 1D tells us that we have foci at 2, -2, and 2, 4, and then we have a major axis of length 10. All right, so what is the semi-major axis? 5, very good. 5, because it's semi means half, right? So it's half the major axis. All right, so we have a foci, we have a focus at 2, -2, which is here. So that's our first focus. And then we also have a focus at 2, 4, so that's here. So where is the center? Good. The center is going to be at 2, 1 because the center is always right in between the foci, right? Has to be symmetrical. So that means the center will be here at 2, 1. Okay. Now we also know that the major axis is 10, so the semi-major axis is 5. But what direction would the semi-major axis go in? Yeah, why?
So.
Yeah, the foci are oriented vertically, and so that means that the semi-major axis must also go up and down.
Like, build it into me. Okay.
Okay? And so that means that one vertex must be here at 2, 6, because that's 5 units. It's 5 units above the center. And that means the other vertex must be at 2, -4, because that's 5 units below. Okay? How do I find the semi-minor axis?
After that.
Huh?
Yeah.
How do I find the semi-minor axis? Very good. So to find the semi-minor axis, we have to use the formula c squared equals a squared minus b squared. What is c squared? 9, very good. It's because c is 3, right? because that's the distance from the foci to the center. And then a squared is 25. So that means b must be 4, right? And so that means our other vertices are going to be 4 to the right and 4 to the left of the center. So we'll have one vertex here at 6, 1, and another vertex here at -2, 1. So our ellipse will look like that. Not very nice looking, but it is what it is. Okay, so now we can find the standard form of the ellipse. So I'm going to write the numerators. Those are pretty easy, right? It's going to be x minus h. So I'm going to look at the coordinates of the center, which are 2, 1. So I know my numerators are going to be x minus 2 and y minus 1. Okay. Now for my denominators, I'm going to think about what my x radius is and my y radius is. So I know that my x radius is going to be 4 because that's half the width of the ellipse in the x direction, right? Because this length is 4. And so that means that the x radius is going to be 4, so I have 16 in the first denominator, and then 25 in the other denominator, because that's the length of the y radius, which is also the semi-major axis. And these should add to 1 if I have an ellipse. Yes.
Why is it again H2 and H1?
Because h and k are the coordinates of the center.
Oh, yeah.
Any questions?
This up while we do the transfer.
Oh,
Can we keep this up while we do it?
shouldn't it be in your notes?
Yeah, it's easier to.
I'm not done with the lecture, so. Let me continue to talk about completing the square and then we'll be done. No, you need a copy again? 3, 2, 1. Okay. Okay, completing the square. So the problem is that for ellipses, you need to complete the square twice because you have 2 perfect squares in the equation, right? So let me do an example and then you guys will be able to do the back page. Let me find the example I used for the previous class. How do I copy this? Copy. What? That would. Never mind. All right, guys, let me do one example and I'll let you guys go. So in order to get the center, vertices, and foci of this ellipse, what I have to do is actually complete the square and get it into standard form. Okay, so I'm trying to get it into the form x minus h squared over a squared plus, etc. So in order to do that, we are going to separate into variables on the left-hand side and get the constant to the right-hand side. So I'm going to move all my x squareds to the starting position, and then I'll move the y squareds to the back, and then the 9 to the other side. Thank you. Okay, and then I'm gonna have to complete the square twice. The problem is that I'm actually not allowed to divide by 4 here, though. Because if I do divide by 4, I'm going to affect the x squared. And so actually we have to be more subtle in how we do this. So for the x squared, that's pretty easy to complete the square. We just add 9. Because 6 divided by 2 is 3, and then 3 squared is 9. However, for the 4y squared, I'm going to have to first factor. So I'm going to factor out of 4, and then I'm going to be left with y squared minus 2y. So what do I add to complete the square for y squared minus 2y? 1, very good. That's negative 2 divided by 2, which is negative 1 in the square, so it's 1. So I add 1. Yeah. So the right-hand side is going to become negative 9, and then plus 9, because I added 9 from the x squared. But then for the y, I'm going to have to compensate that by adding plus 4. Not plus 1, but actually plus 4. The reason for that is because I added plus 1 within the parentheses. Okay, so in reality, I actually added by 4, because there's a 4 in front that's multiplying this plus 1. And so you can't just add plus 1, you have to add plus 4, because that's actually how much you're adding. Make sense?
Yeah.
And so if I simplify this, I'm going to get x plus 3 squared plus 4 times y minus 1 squared equals 4. Is this standard form? No, it is not standard form because I do not have a 1 on the right side. That is of essential importance. So I have to divide both sides by 4 in order to get standard form. So I'll have x plus 3 squared divided by 4 plus y minus 1 squared divided by 1 equals 1. So that is standard form. And then center vertices foci, you can figure that out. Eccentricity, let me talk about that. For every ellipse, there's a constant called eccentricity. That's just going to be c divided by a. And so eccentricity will always range between 0 and 1. If the eccentricity is 0, that means c is equal to 0, right? So what does that tell us about the foci? They are on top of each other. They're not separated at all, right? And so when the eccentricity is 0, actually you have a perfect circle because the foci, they are at the same point. Eccentricity 0.5. So as eccentricity increases, it becomes more oblong. You guys know that word?
Or what?
Oblong. So this is 0.5. And then as eccentricity approaches 1, it just gets more and more flat. Okay, I'm done.
Your example, being the squares, it happened